Hello everybody. The plan for this video is to recap some of the ideas that you've seen involving straight lines at GCSE level. So I've got this formula, one I made earlier, which is y equals 2x plus 1. So it's a fairly simple link between these two letters, x and y. If you want to get y, you need to times x by 2, and then you need to add 1. So a fairly simple link. X can be pretty much any number that you want it to be. So I'll start with some real simple numbers. For example, x is 1. So if I took that formula and substituted x is 1 in, then I would get a y value out of 3. And these two ingredients, x is 1, y is 3, that produces a coordinate. X is 1, y is 3. And that is just a single point on this straight line. Now we can continue to put numbers in. So if I, for example, plugged in 2, I would get, in this case, I'd get 5 out. And again, I'd have a situation where I have another coordinate, and I can start plotting them on my graph. Alright, so I've just plotted my points on. They're looking real nice, real colourful. And I can plug any number in for x, really. And if I just automate this with my table, so I'll plug in 0, I'll plug in -1, I'll plug in -2, and I'll plug in some bigger numbers as well, so I'll plug in 3 and 4. And you can see that for every x value that I'm putting in, I'm getting a different value out. Now, all of these combinations produce coordinates. And if I plot all those coordinates on, boom, I get a nice straight line. And this straight line is the line 2x plus 1. Alright, so you'll have noticed that I've cut out a section of my graph and I've zoomed in a little bit. This is because I wanted to look at some of the intricacies behind this equation and the link between the algebra and the geometry. So let's talk about this plus 1 first of all. This number that's on its own in the equation is known as the y-intercept. So if you look at your y-axis, which is all along here, you'll notice that the straight line cuts through the y-axis at 1. Right? So that's what our leftover 1 tells us. The 2 in front of the x, this number here, is the gradient. And the gradient is a measurement of steepness. So if we go into this a little bit more detail, if we go from this point here and we go across 1 square, so we've gone across 1, notice that every time we go across 1 square, we're going up 2 squares on our straight line. So that's what the 2 represents in the gradient. Every time we go across 1 square, we're going up 2. So it tells us how steep something is. So we've just been talking about the straight line y equals 2x plus 1, where the gradient was 2 and the intercept was 1. But you might have come across this formula as well for straight lines, y equals mx plus c. And basically what this formula says is it doesn't matter what number you have here, m, or what number you have here, c, whatever these values are, you're going to get a straight line equation out. Right, so if I just change the value of c, off it goes, you notice that it's moving up and down. Right, and that's because the place where it crosses the y-axis is constantly changing and I need to move my screen with it. So let's just pause that for a second. There we go. So at the moment, c is 7.6. So if we have a look at the y-axis to see where it crosses through at 7.6. Of course, the gradient can be something that we change as well. So if I change the gradient, if I increase that, it's going to become a steeper line. If I decrease it, it's going to become less steep. There we go. Notice that if I have a negative gradient, the line will sort of swap directions. So it'll go diagonally from top left to bottom right. A positive gradient is obviously this way around. So notice, oops, meant to pause it there. we'll let it swing back around. Off it goes again. It's like the awkward pirate ship. Hey, all right. So let's have a look at a gradient of like 3, for example. So if I zoom in on this, if I take any point, let's move the intercept on 7. There we go. So if I look at this square here, if I'm going across 1 here, I'm going up 3. There we go. So you can see the geometric sort of significance of the gradient there. So yeah, those are some of the ideas you might have encountered at GCSE level. Hopefully that's useful in sort of reminding you what you might have encountered back then.